moving forward. So I have one example problem to work through here. Let me see what the next slide after that is. Yes, okay. So just one example that I'm going to go through, and one more brief slide after that, and then that'll be done for this video, okay? And so this is going to be good practice because this is going to give us not only practicing the solubility rules for this problem, but also doing a limiting reagent problem, because believe it or not, this is actually a limiting reagent problem. So let's see the problem. It says, when aqueous solutions of sodium sulfate and lead nitrate are mixed, a reactant precipitates. Okay, stop. I'm not even going to read anything more. I can see that I don't have a reaction, so I have to get a reaction out of this. So it says, when aqueous solutions of sodium sulfate and lead nitrate, so this is actually lead 2 nitrate, mix, okay, a precipitate forms. We have to figure out what that is, okay? And what I can do here, because I'm working on the full formula equation, I can automatically see that it's going to have to either be lead and sulfate or sodium and nitrate. Okay, so I'm going to write that down in pen, a different color, right? I'm going to exchange the cations and anions. So there are my options as to what is going to be the possible product. And right away, I'm just going to go ahead and write those down. And so I remember that sodium is +1 and nitrate is +1. So that becomes NaNO3. But I can see that I have 2 sodiums here and 2 nitrates here. So I'm going to put a 2 right in front of there to balance. And I'm not sure what the phase of that product is yet, if it's aqueous or solid. And then my other option is lead and sulfate. So from this formula, I can tell this is lead 2+. And I know that sulfate is 2-. So that's going to be PbSO4. And I'm not sure what the phase of that is either. So let's go back and look at the solubility rules, okay? So, I remembered my rule for nitrate, that basically everything with nitrate is soluble. And then I can see, oh, here I have sulfate, and sulfate is supposed to be soluble except when paired with lead. Okay, so lead sulfate is an exception on the solubility chart, on the soluble chart. That means it's insoluble, and insoluble means this is the solid, and the sodium nitrate are the spectator ions. Okay, so this is the product that we're interested in. And so now the problem tells me, calculate the mass of reactant formed. Okay, so how many grams of the lead sulfate when 1.25 liters of a 0.05 molar lead nitrate solution and 2 liters of a 0.025 molar sodium sulfate solution are mixed. This is how I know that this is a limiting reagent, because I've been given amounts of both reactants. So now I'm going to erase this red ink right here, because now I'm going to put different information there, okay, to tell me, to kind of help me guide my calculation. Okay, so this is what I'm trying to do. I'm trying to get to grams of lead sulfate. And I know that I have 1.25 liters of a 0.0500 molar solution of this and 2.00 liters of a 0.250 molar solution of this. And just like my true limiting reagent style, first I'm going to do one calculation, right, starting with the lead. And then I'm going to do a second calculation starting with the sulfate. And we remember that the least is the most, okay? So let's get that going. I'm going to say number 1 here, number 2 here, and let's do it, okay? And so I also remember, hopefully I remember, that when I have a volume and a molarity, I don't need the molar mass. So remember, when I have volume times molarity, it directly gives me moles. So I don't need the molar mass of any of these things, which is great. Hallelujah. Okay. So now I'm going to start by saying 1.25 liters of the lead nitrate. Okay. And remember how I can use this molarity. Remember, 1 molar means 1 mole in 1 liter. Well, I don't have 1 molar, I have 0.05 molar. And so what that means, in 1 liter of this solution, I have 0.500 moles of lead. And I'm just going to write Pb2 plus because really that's the stuff that's reacting. Okay, we could have wrote lead sulfate there and that would have been okay. But I recognize that it's really the lead that's important. And in this reaction, it's 1 mole of lead makes 1 mole of lead sulfate. 1 mole of lead nitrate makes 1 mole of lead sulfate. So I can say now 1 mole Pb2 plus makes 1 mole of PbSO4. Oh, I ran out of room here with my red arrows. And then now, because it's asking me to calculate the mass of precipitate, I need the molar mass of the PbSO4, okay? I need that molar mass. And I did that already. It's a pretty heavy sucker. I just did it to 3 sig figs. 303 grams of lead sulfate in 1 mole of lead sulfate, okay? And so when I do that, the answer I get is 15.2 grams of lead sulfate, starting with the lead, okay? So now let's start it with the sodium sulfate solution instead. So I'm going to start with the 2.00 liters. I recognize in 1 liter of that solution, there's 0.0250 moles of sulfate. So sulfate is the important ion. That's the one that's reacting. Okay. And then in this reaction, it is still a 1-to-1 ratio, right? So that's cool. So 1 mole of sulfate makes 1 mole of lead sulfate. And then now I can copy that very last line because I know I need to convert it into grams. And so I just use the molar mass of lead sulfate, 303 grams per mole. And when I do this calculation, so I've got them all written down. So I'll go ahead and calculate them out since I got my calculator. Let's do this top one. So I was just kind of using my cheater notes, but you can see now where I get these numbers. 1.25 times 0.0500 equals, and then times 303. What did I do wrong? Did I write down? Oh my goodness. Okay. So yes, this is why I should do this, because you can see that I copied down the wrong answer. So this one is 18.9 grams. And what do you want to bet that this one's going to be the 15.2? Okay, so now let's do the number 2, okay? So 2.00 times 0.025 equals, and then times 303 equals, haha, that one is the 15.2. Good thing I did the calculation. Okay, so that means this is the most amount that can be formed, which of course means our sodium sulfate was limiting, meaning we would have excess lead nitrate reagent. Okay? So, and just kind of, again, reiterating, this is the important thing. What's going on is being able to use this solubility chart as well as being comfortable breaking up these ions into breaking up these compounds into their respective ions and then forming new compounds by doing that double displacement, by exchanging cation and anion. So if you're still not so comfortable with this, this is a great place where you need to be practicing to get good at these precipitation reactions. And I wanted to say, and the net ionic equations. Yes, and being able to, as this eventual goal, get the net ionic equation. Okay. So the last thing that I'll say is, what does it mean to be saturated? Okay. So we noted that NaCl is soluble because on that solubility chart here, right, there's chloride. Sodium is not an exception, so sodium chloride should be soluble. However,